All right, ladies and gentlemen, it's time to have your first lesson for Chapter 11, and this one is called What is T? So, as you've probably looked through the book already, you'll realize that we are moving away from normal distributions and we are going to start talking about something called the T distribution. So, I think some important things to note as of right now. Everything that we've been working on has been z-based, meaning that we are using the normal curve as our means of generating probabilities. And whenever we're using z-based test statistics or z-star values for critical values, we were always doing things that were either a known standard deviation, so we knew sigma if we were doing a mu-based problem, or we were working with proportions and using the binomial proportions, using the binomial approximation or the normal approximation to the binomial with the np and the n times 1 minus p checks to get to normality. And as we move back to chapter 11, you're going to see that all of the things that we're going to be working on are actually going to be mean based again. So we're going to be dealing with mu. However, we're moving away from kind of a false sense of knowing. We've claimed to know what sigma is all of this time, and in reality, if you're doing inference for mu, why would you ever actually know the population standard deviation? It would require you know the population mean, seeing as sigma is a mean-based statistic itself. So the big kind of point that we're going to be making is that, sigma is now going to be gone, and it makes completely logical sense, and I'm sure that you've been wanting to do it forever, that instead of using sigma, we are going to be using standard deviation for the sample S, or if you want to call it S sub x. These are sample standard deviations as approximations of sigma. So what T is, what is T that we're talking about? T is a new test statistic that we're going to be using, a new critical value that we'll be using in confidence intervals. And in its easiest form, T looks a lot like Z, but instead of using sigma, it uses S. So it's going to be some sample minus some claimed mu naught value. And in the denominator, instead of having sigma divided by the square root of n, we're going to have s divided by the square root of n. That's the ugliest square root sign I could have possibly drawn for you. I apologize. And now that we're dealing with s divided by the square root of n, we are again dealing with the standard error of something instead of the standard deviation. In this case, standard error of x bar instead of the standard error of p hat, which we were just doing. So we're going to be using T, a new distribution, much like we used Z, to generate probabilities and to generate confidence intervals. All right, so drawing you a couple of distributions here, and at the top, really this is the key, and this is what is completely different than what we've been dealing with before. We were always able to generalize things down in a normal distribution, usually to one particular distribution called the standard normal distribution, which remember is centered at 0 with a standard deviation of 1. And from there we were able to generate our z and generate our probabilities. With t distributions, there is no standardized t distribution. T distributions are actually infinite. There are an infinite number of t distributions, and the reason why is t distributions are sample size based. So every different sample size has a different distribution, which sounds like it'd be really, really, really crazy. It's a little bit more crazy than Z, but you'll see that it's going to behave very similar in terms of how we go about generating particular probabilities and t-star values. So what I have drawn for you is a similar example to a graph that we looked at earlier in the year when we were just talking about variability. But you'll see that the red graph is the graph of n equals 10, and it looks as if I've drawn a normal curve. It's not a normal curve. This is a density function that is based off of standard error of x bar, not standard deviation of x bar. So you'll see that it goes up and it kind of peaks out here, and at its peak it begins to drop down, and there's definitely a bit of area in the tails of the distribution, therefore making the center of the distribution lesser in height than that of n equals 20. And again, the general rule being, we know that as sample sizes increase from 10 to 20, variability about the mean is going to decrease. Therefore, you're going to get a larger amount of values closer to the center for your sampling distribution, and therefore your tails will have less area in them. So we're going to have to be very, very, very cautious about which distribution we're using, and we're going to base that on the sample size. Now, of note, you should notice that, going from 10 to 20 is actually a fairly sizable increase in sample size. And if you were to take the average of 10 things versus the average of 20 things over and over and over again and generate a sampling distribution, we understand that the 20 will definitely have smaller variability. But as we get up in size and we start talking about n equaling 50 and n equaling 75, we should recognize that the difference between the two lower values from 10 to 20 is a more significant difference than it is from 50 to 75. That as n gets large enough, any outlying values will probably be balanced with the other 49 or 74 values that are in the sample, and therefore there's not much of a difference between the sampling distributions for the t-distribution of n equaling 75 and n equaling 50 versus 20 and 10. So expect big differences between these two. Don't expect very large differences. There will be differences, but not very large differences, because tail area at high n values actually becomes pretty marginal at best. So that's a little intro into the distributions that we're going to be using. I hope that you either take some notes quickly or keep these videos handy if you need to refer back to them. Again, they should be a supplement to your reading. They should not be the only means of exposing yourself to the T distribution. So make sure you get back to that book. There's 2 more videos for what would be section 11.1 in your book, so make sure that you watch them as well. All right, good night.